Hi folks, it's Dave from Dev Playbook. Thanks for checking out our video today. If you want to see more courses, videos, how-tos, and content like this, visit us at www.devplaybook.com and subscribe to our mailing list for occasional content updates. You can also follow us on Twitter at dev_playbook. Now enjoy the video. Hi folks, this is Dave from Dev Playbook, and this is the first in a series I'm starting up called SQL Real Fast. It's intended to give you some relatively quick walkthroughs of common functionality, tips, tricks, and features of SQL across multiple database platforms, including SQL Server, PostgreSQL, and MySQL. Today I'm going to cover a topic that I've written about on devplaybook.com, and that is using a SQL database to store and interact with JSON documents. And in this session, we'll cover Microsoft SQL Server as the first part in this little series, and then we'll do PostgreSQL and MySQL. JSON has become more or less the language of connectivity these days. It's the glue that allows us to bind systems together through APIs, automate business processes, and extend our applications. And in order to facilitate storing and processing data in JSON documents, we've seen the rise of NoSQL databases like MongoDB, Hadoop, and Redis, to name just a few. These database platforms don't use the terms table and row and column necessarily, but rather they store fields in documents which are formatted using JSON, and those documents get stored in collections. There's a lot of upside in the NoSQL structure because it gives you a tremendous amount of flexibility in that you don't have to constantly change your data schema every time you identify a new piece of data that you need or want to store. However, there are countless systems and applications that still rely on good old SQL databases to handle transactional processing and analytics, and that's probably going to be true for as long as we can imagine. Now, that doesn't mean you won't find a use for a NoSQL type document storage solution in your apps. But adding a NoSQL database to an application that primarily relies on SQL databases could increase the complexity of your application and your infrastructure and your deployment processes. Fortunately, all of the major relational database platforms have implemented some level of support for JSON document storage, manipulation, and querying in recent years. So let's start with the use case described in the article on Dev Playbook. And since I've spent a good deal of time working in healthcare, I picked a scenario that's familiar to me personally, and that is a health insurance company that needs to be able to track the contracts that it has in place with healthcare providers like hospitals or clinics. These contracts are actual legal documents that will outline various terms, and some of those terms will include payment terms like fixed fees or calculated percentages for specific services. I actually think that storing provider contracts in a JSON document makes a lot of sense. These contracts can change frequently, and sometimes you have terms that can be somewhat unique based on the contract or the hospital. So if you have to add fields to capture those terms to a relational database, you might end up with a very messy structure. A JSON document makes sense because you can extend the document relatively easily without having to redefine the schema, and you can handle that flexibility within your application. So let's use that use case, and we'll create a simple schema to store our providers and contracts, and then we'll dig into how we can go about storing JSON documents in the database and then querying them. I've gone ahead and created the database schema that we'll use for these demonstrations, and here what I have is I have a provider table, and this provider table simply has an ID field, a provider name that's a varchar 5, and then an MPI that's a varchar 10. We then have a provider contract table, and that provider contract table has an ID that's our primary key. We have a provider ID, and this is actually a foreign key to our provider table. We have contract terms, which is defined as an invarchar max, and this is where we're going to store our JSON document. SQL Server doesn't give us a specific JSON data type to use. It just has us store it in an invarchar max field. Then we have a contract effective date and a contract termination date that we're capturing. Because these are going to be common for every contract that we create, we're going to put them in their own separate fields. So the first thing that we're going to do is we're going to populate some data, and what we're going to use, we're actually going to use the data that's in the article that is in the link below. We're going to go ahead and run that. We're going to create our two providers, Princeton Plainsboro Teaching Hospital and Sacred Heart Hospital. And if I go select all from provider, we just want to make sure that we've got what we expect. ID is 1 for Princeton, and ID is 2 for Sacred Heart. So we're good there. And then the next thing we're going to do is we're going to run insert queries for our provider contracts. This will create a contract for each one of these providers. So it looks like we're in good shape there. Let's select all from provider contract. And here we have a contract for provider ID 1 and a contract for provider ID 2. And you can see if we double click here that we have our JSON document and everything that's there. Let's take a quick look at the structure of the JSON documents real quick before we go any further. So this first one is the one for Princeton Plainsboro Teaching Hospital, and you can see that we have an out of area indicator up here at the top level, and then we have a service rates, and that's an array of objects. And each service rate object is going to have a service description, a service code range start, a service code range end, and then either a flat rate or a build percentage. And then down here for Sacred Heart, you can see that we have an out of network indicator, but we don't have an out of area indicator. So let's take a look at some queries that we can run. First of all, we've gotten our data into the database. Let's look at how we're going to interact with it once we get these JSON documents in there. We'll take a look real quick at a couple of functions that we'll use in SQL Server to do this. There are 5 different functions that SQL Server provides us with in order to be able to interact with our JSON documents. And we're going to talk about 4 of those today. We are going to leave the JSON modify document for another time. But we're going to talk about the isJSON function. And that one's going to return a 1 if the contents of the column or the variable that we pass to it are a valid JSON document. And it's going to give us a 0 if the contents are not valid. And it'll give us a null if the contents are null. The JSON value function is going to give us a scalar value from the path that we provide if that path has a scalar value. Otherwise, it's going to give us a null. The JSON query is going to return a JSON object from the path that we provide. So we can use this to return an array from within the JSON document, for example. And then the openJSON function is going to allow us to essentially convert a portion of the JSON document to a table value. And we're going to have an example where we combine this with a with clause to map columns in the table to specific JSON paths. And then JSON modify allows us to modify a value within a path. So let's start out by taking a look at the isJSON, and then we'll look at the JSON value. We'll do some work with openJSON, and then we'll wrap up with a JSON query example to see how each one of these works. All right, the first thing that we're going to test out is going to be the isJSON function. And again, because SQL doesn't provide a dedicated JSON data type, we have to basically look at our invarchar max, and we have to determine if it contains a valid JSON document before we try to use it. So we can do a select from provider contract, and we're going to select the ID. Let's select the provider ID. Let's select isJSON contract terms as is valid JSON. And remember that we're going to get a 1 if it's valid, we're going to get a 0 if it's not, and we're going to get a null if it is a null value. And here you can see that we have valid JSON in both of the records that we inserted. So that's a good sign. So next, let's look at querying these documents that we've stored using the JSON value function. So our isJSON function returned exactly what we wanted to. So now let's do a query to actually filter on and retrieve specific information from within the document and see how that works. And we'll use the JSON value function to get scalar values for out of area and out of network. So what we'll do is we'll say select the ID, and then we'll select the JSON value, JSON underscore value, from the contract terms field, and then we're going to provide a JSON path to the document root and to the out of area variable or field within that as out of area. And then let's do another JSON value, and we're going to say contract terms, and then we're going to go to the document root and then out of network as out of network. And we're going to select that from provider contract. So let's go ahead and run this first. And we're going to see that we get two records. The first one is going to have an out of area of true, and the second is going to have an out of network of true. They're going to have null values where those fields don't exist. So out of network, we did not have an out of network field in the JSON document we added for Princeton-Plainsboro. We did not have an out of area field for the JSON document we added for Sacred Heart. Now, we can also use our JSON value in our filters. So we could say where contract terms, and then we'll specify, for example, out of area is equal to true. And then we're going to run that, and we're going to see that we're actually getting just the Princeton-Plainsboro where we have a true for the out of area. So that works pretty well, and it's fairly intuitive. We're using JSON pathing to define where in the JSON document we want SQL to go to get the value, and we are expecting to just get a scalar value, just a single value from that document. And I will note that if you want to get some value from, for example, our service rates, which is an object array, then we're going to have to know specifically which index of the array we want to go in order to get, or in order to use that or enable to access that. So let's take a look at another query that we can do to be able to capture that information. So let's say that we want to get the flat rate for an office visit for, let's say, Princeton-Plainsboro Teaching Hospital. Well, in order to do that, there are a couple of different ways that we can approach it. If we know exactly which service rate, in terms of which index in the array we're looking for, then we can do that using JSON value. So let's say that we're going to do a select from provider contract, and then we're going to join provider. So we'll just do this. And let's say that we want to get the provider ID, the contract ID, and then we want to get the provider name, and then we want to get the flat rate. So we're going to use JSON value. We're going to get the flat rate from the contract terms. And we're actually going to go to the service rates, and we're going to go to the first index of service rates, which will be 0, and we'll grab flat rate. And that's going to be as office visit rate. All right, and we'll go ahead and run that. Now we can see that what we're getting here is we're getting Princeton-Plainsboro Teaching Hospital, and we're getting the office visit rate of 45. And in fact, I'll just go ahead and add contract terms in here just so that we can get that as well and see what the document itself looks like. And then if we look at this, our service rates, our very first index, we have an office visits 1. And then we have our start and end range for our service codes, and we have a flat rate of 45. When we look at Sacred Heart, they don't have a service rate that has a flat rate at all, so it's not returning anything there. And then what I can do here is I can say where the JSON value of the contract terms, and then we're going to go to the path of service rates 0, and then we're going to go to the service description, and we're going to filter that to where it's equal to office visits 1. We'll run this, and then we're only getting Princeton-Plainsboro Teaching Hospital. So as you can see, if we have an array of objects, in this particular instance, we're actually having to know exactly which index we need to go to. Well, that's really inconvenient, and you usually don't know exactly which one, or you may not know exactly which array index you're going to have to go to get that particular object, so that you can know what is the flat rate for an office visit 1. And in fact, what if that office visit 1 is the 3rd or 4th or 10th object in that array? You're not going to get it with this query. So let's look at how we can do that with the open JSON function. So what we'll do is we will start by defining a variable, and we'll show a couple of ways we can do this. This isn't the only way to do it. As with most things, there are multiple ways of accomplishing the same thing. So what we'll do is we'll define a variable called JSON, and then we're going to use the JSON query function, and we're going to go to contract terms, and what we'll do is we'll select our service rates, and this is going to give us the array of objects that we want. And we'll select that from provider contract, and then we'll just say where the ID is 1, and then let's print JSON. We're going to go ahead and run all of these together. And then if you see down here in my console, I actually have some JSON that gets printed, and it shows my service description, office visits 1. If I continue looking, here's office visits 2, and then over here I have anesthesia. So I have 3 different objects. So this has gone in and gotten me my service rates array out of that particular document. Now what I can do is I can take that JSON function, and I can select from open JSON, and I'll pass the JSON variable over. And then we're going to do a with query, and that with query is going to allow us to say our service description. We're going to call this an invarchar 100. We're basically going to build our table right here. And this is going to get our service description there. Service range start. And then that's going to be an invarchar 100 that will make it, actually probably isn't quite that large, but it's okay. We're going to go to service code range start, service range end. We're going to go to the service code range end. And again, this is going to the root of the document contained within the JSON variable. We'll get end right there. And then let's get flat rate as a decimal. So you can see how we're defining the data type that we expect to be in our JSON document. There's our flat rate, and then let's get our build percentage. And that also is going to be a decimal. And then we'll do, here's our $sign dot build percentage. Okay. And then we're going to call this little table, this little subquery JS. We'll do a cross apply to provider contract PC. And then let's do an inner join to provider on the provider ID is equal to provider ID right there. And then we're going to go ahead and apply, let's say we're going to do where the provider contract ID is 1, and let's say where the service range start is less than or equal to, and we'll do 99215. So what we're looking for is we have a specific service code that defines what the doctor did, or what the provider or hospital did. And then we want to pass that service code in and say, give me the service rate where this code is between the start and end range. And then we just need to define a few fields that we want to pull back. I'm just going to copy and paste those to save some time. And then I'm going to select all of this and I'm going to run it. And it's going to return back to me my provider name, NPI, ID, the provider ID. Here I have my contract effective and term dates. And then you can see that from my JSON document, I've gotten my service description, my start range, my end range. So you can see that we filtered on 99215, which falls between my start and end range. Here's my flat rate, and the billable percentage, or the build percentage here, is null because I don't have that defined for this particular service rate. So this is one way that we can do it. We can define a variable. We can select our contract terms, the service rates array specifically using the JSON query, which basically extracts a specific portion of that JSON document into a separate JSON document. Another thing that I could do is I could actually pass this query itself over to my open JSON, and I'll just encapsulate that in parentheses. So then I just pass that to my open JSON function, and then all I have to do is just run this right here, and you can see that I get exactly the same result when I run that. So I don't necessarily have to declare the JSON variable and then select it. The print line here is really just for me to be able to see what's coming back in that, so it's just a debugging line. So I don't necessarily have to do this. I could actually just run my select query right here, which makes things a little bit easier. You can still tell that it's a fair amount of work to have to deal with this within SQL Server, but there is a way that you can basically say, convert this piece of a JSON document into a table and then join that table to my other tables, and you can then start to use the fields from that table in your where clause, which becomes very convenient, and it gives you quite a bit of power. So one more thing that we'll do is we'll take a look at how we can get a JSON document out of SQL, and where the data doesn't necessarily even have to be in a JSON document to begin with. It can simply be sitting in columns in one or more tables, and we'll use the JSON query function to do this once again. So the last thing that we'll do is we'll take a look at how we can run a query to get a JSON document out of SQL. And the data doesn't even have to be in a JSON document. It can just be columns sitting in a table. So I'm going to clear out my query that I ran here, and I'm going to start, and we're going to select from providers, or from the provider table, and we're going to join the provider contract table, and I'm going to actually call this contracts because I want it to have a specific I want it to come back in a specific way within the JSON document. So we're going to say contracts.provider ID is equal to p.id. So we have that there. So let's go ahead and let's get the provider ID, and let's get the provider name, and then let's get the contracts ID, and then we're going to get for now, let's get contracts.contract effective date, and then we'll get contracts.contract term date. So we're going to get those. Now, if we run this query, you're going to see we are going to get our usual tabular output with 2 records. But what we can do is we can say for JSON auto, and we're basically just going to tell SQL to automatically take our tabular output and convert it to a JSON document. And when we do that, you're going to see that we're going to get a JSON object array that gets returned. Here you can see we have an ID of 1, provider name is here, and then we have contracts, and that's going to come back with an array of objects. We have our ID, our contract effective date, and our contract term date. And then here is our second provider object, and that's got our Sacred Heart Hospital, and that's got the contract for Sacred Heart Hospital. So if we had multiple contracts for Sacred Heart, which is a possibility, we would have multiple objects within this array as well. So it's going to take our query and it's going to convert it to a JSON document for us. Now, if I don't like the fact that this comes back as just an array, I can provide a root option here. And then I can run this, and you're going to see that it will come back and it will actually create a JSON document, and it'll provide providers at the root and then my object array after that. So it gives me some flexibility and some control over what comes back. Now, if I want to get the contract terms in there, the contract terms is actually a JSON document, and I can come in here and I can say, let's do JSON query, and we'll do contracts.contract terms, and then we're just going to return the root of the contract terms, and then we'll call that contract terms. We're going to run this, and it's immediately going to return back to us, and you see it's pretty fast. It's going to return back to us our contract terms, and here is the object right here. We've got our out of area, and then we have our familiar service rates array of objects that comes back there. So you can actually see that we can return a tremendous amount of data with a very simple column, and that can be easily formatted into a JSON document. So that will wrap up this episode of SQL Real Fast, and it was probably not as fast as I'd like it to be, but I do thank you for diving in and sticking with me. It was a lot of fun to put this together, and it's been a lot of fun to share it with you. Feel free to visit us over at devplaybook.com. There is a mailing list there. We send out occasional emails with updates for new content, new courses, new videos, and other types of things that you might be interested in. We are focused on database development at the moment, but we do plan to spend a good deal of time in web development across numerous technologies throughout the year. And so please feel free to subscribe to the YouTube channel, follow us on YouTube at dev_playbook, and then visit us at devplaybook.com. Thanks again for your time, and I hope you have a great day. Hi folks, this is Dave again. Thanks so much for watching our video today. We've got more where this came from, so subscribe to the YouTube channel to get more videos, share with your friends as always, and visit us on www.devplaybook.com for more courses and content just for developers like yourself. You can also follow us on Twitter at dev_playbook. Thanks again and have a great day.